Hello students, this is Professor Chalai, and in this video we're going to look at enthalpy, exothermic, and endothermic processes. As always, you can follow along with our Chapter 5 workbook. By the end of this video, you should be able to define enthalpy and identify exothermic and endothermic processes. Let's get started. So what is enthalpy? Enthalpy, we use the symbol H to represent enthalpy, is a state function. We talked about state functions in our previous video, but enthalpy is one of those. It's a state function and it's measured at constant pressure. It is equal to the internal energy plus the pressure times volume. How do we get it? Well, let's think back to our change in internal enthalpy, internal energy equation from earlier. We talked about how the change in internal energy is always going to come from the heat plus the work. But we talked about how work is going to be equal to negative the pressure, the external pressure, times a change in volume. So if we solve this equation for Q, then we will get Q is equal to the change in internal energy plus the pressure times the change in volume. This heat for a constant pressure, so let's call it constant pressure P. This heat at constant pressure, we're going to call a change in enthalpy. So change in enthalpy is a change in internal energy plus the pressure times the change in volume. This is the equation that I have up here. This is how we got there. A change in enthalpy is a change in internal energy times the pressure times the change in volume. The pressure is not a change because it's at constant pressure. This is what the little p there represents. It's a heat at constant pressure. And that's what enthalpy is. Our enthalpy change is just the heat at constant pressure. We're never really interested in just the enthalpy of systems. We're always interested in the change in enthalpy of systems. All right, so let's keep that in mind. But as we're thinking about enthalpy, note that most of the heat experiments that we perform, for example, in our labs, on the tops of desks, are actually measurements of enthalpy because the external pressure, if it's open to the air, the external pressure is constant, right? The air pressure is constant. So most of those heat changes that we measure are actually enthalpy changes. Okay, so let's get back to a more in detail definition of exothermic and endothermic processes. So an exothermic process, in an exothermic process, the change in enthalpy would be less than 0. It's negative. Negative. So in an exothermic process, the change in enthalpy is less than 0, meaning that the system lost heat energy to the environment. This is measured at constant pressure. And for an endothermic process, the change in enthalpy is greater than 0 or positive, meaning that the system would lose heat energy to the environment. So let's think about this, right? If the system, if the enthalpy change of the system is less than 0, this means that the enthalpy change in the environment will be greater than 0. Or rather, the environment will gain thermal energy. So if we wanted to know if something was exothermic, this is exothermic, then the environment is what we measure, right? We always measure what's going on with the environment, changes in the environment. So the environment, the enthalpy increases, which means that the environment gets hotter. Similarly, if the change in the enthalpy for the system is greater than 0, it means that the environment, right, would have lost enthalpy. And that means that for endothermic process, so this is an endothermic process, the environment that we measure So the measured environment gets colder. So if something gets colder, then we know that that process, if the environment gets colder that you measured, then you know the process was endothermic. If the environment gets hotter, then you know that the process resulting in that resulted in the environment getting hotter was exothermic. With that, I would like you to think about all of these different processes in question 17 and write whether you think they're exothermic or endothermic next to them. I'll let you, I'll have you pause the video here and go through each of those, and then you can unpause and I'll go over them with you. Okay, so let's look at sweat evaporating from the skin. When your sweat evaporates, it cools you down. You are the environment. The sweat evaporating, that's the system, that's the process. So you get cooler, which means that this process is endothermic. Water freezing in a freezer. This one is a little bit interesting. So think about it. Water freezing in a freezer. You might be thinking, well, the water is freezing. The environment might be getting cooler, maybe? Actually, what happens is as the water freezes, so you can imagine in a water molecule, or sorry, in liquid water, the molecules of water are all moving around haphazardly. And then as it freezes, these molecules stop moving around and gets locked up in a nice ice crystal. So the kinetic energy and other types of energy associated with the motion in liquid water gets removed, and it forms the solid ice crystals. So that energy gets released into the environment of the freezer as heat energy, and then the freezer is just there to take away the heat energy. So in water freezing in a freezer is actually an exothermic process. Okay, let's think about wood burning in a fire. The fire is part of the heat energy that's released as wood burns, so this would be exothermic. Ice cube melting. This is actually the opposite of water freezing, right? Ice melting, ice forming. So as an ice melts, it cools down the environment around it, right? It cools down the environment. This is why it's useful in keeping your drinks cool. The ice melts, keeps your drinks cool. So ice cube melting would be an endothermic process. Nail polish remover quickly drying after being applied to skin. Some of you might have tried this out. Same as adding rubbing alcohol onto your skin. You notice that as it evaporates, as it dries, it cools your skin down, meaning that this is an endothermic process. And finally, gasoline burning in a car engine. The gas burns, release heat energy, drives piston, all that good stuff. This is all an exothermic process. All right, hopefully you got all those correct. In our next video, we're going to actually look at thermochemical equations, where we're going to be looking at how enthalpy affects enthalpy changes that are associated with chemical reactions. I'll see you then.